From the smallest moon to the largest planet, almost every world we've discovered has one thing in common: it's round. But why? Why does the universe seem obsessed with shaping its worlds into spheres, while asteroids, comets, and rocks remain irregular and jagged? What is it about the laws of physics that insist on roundness when a planet is born? The answer begins with a simple, powerful force: gravity. Gravity pulls everything toward the center of mass. No matter where you are on a planet, gravity is always tugging you toward its core. When an object in space becomes large enough, its gravity starts to overpower everything else. The rigidity of its rocks, the uneven bumps of its surface, even its motion through space. Over millions of years, that pull reshapes the object, smoothing out its rough edges and drawing every atom closer to the center. The result is a sphere, the most stable shape possible under the influence of gravity. Think of it this way: gravity doesn't like corners. Sharp edges and irregularities create uneven forces. But a sphere spreads weight evenly in all directions, keeping the force balanced at every point. It's the universe's way of finding harmony, a natural geometry of perfection. Even if a planet starts off as an irregular lump of dust and rock, as long as it's massive enough, gravity will eventually sculpt it into a ball. There's even a name for this balance: hydrostatic equilibrium. It's the point where gravity pulling inward is perfectly balanced by pressure pushing outward. Once a celestial body reaches this state, it becomes round. Planets like Earth, Mars, and Jupiter all achieved hydrostatic equilibrium billions of years ago. Smaller bodies like asteroids or comets don't have enough mass for gravity to smooth them out. That's why they look lumpy or potato-shaped. But roundness isn't always perfect. Planets spin, and that changes everything. When a planet rotates, centrifugal force pushes outward along the equator, slightly flattening the poles. This is why Earth isn't a perfect sphere, but an oblate spheroid, wider around the middle and slightly squished at the top and bottom. Jupiter, which spins much faster than Earth, is even more flattened, with a visible bulge around its equator. Rotation also affects how planets distribute their atmosphere and oceans. Gravity pulls evenly, but spin causes differences in pressure, shaping weather patterns and even determining how storms move. The beautiful rings of Saturn, for example, exist because the planet's rotation and gravity reach a perfect balance that traps countless particles in orbit. It's the same physics, the same cosmic rule, repeating itself in different forms. But what if a planet didn't follow these rules? What if something stopped gravity from shaping it into a sphere? In theory, that can only happen if the object is too small or spinning too fast. If an asteroid were somehow frozen mid-spin, it could keep an odd shape. But as soon as it grows more massive, gravity wins again. That's why size matters. Gravity's power increases with mass, and with enough mass, roundness is inevitable. Even stars obey this rule. They form spheres because gravity pulls matter inward equally from every direction, while nuclear fusion pushes outward from the core. Every sunrise you see is a reminder of that perfect cosmic balance, a giant ball of plasma held together by the same laws that shape the world orbiting around it. But roundness is more than geometry. It's a symbol of how the universe seeks balance. Every atom, every mountain, every world is being tugged toward equilibrium. The universe doesn't like chaos. It prefers symmetry. And yet, even within that perfection, there's diversity. Some planets are smooth and calm, others stormy and violent. Some are heavy and metallic, others light and gaseous. But all of them in their own way are trying to become the same thing: round, stable, balanced. Now imagine a world that isn't round, a cube-shaped planet for instance. On such a world, gravity would still pull toward the center, but the corners would be unstable. Mountains would collapse inward, oceans would flow toward the middle, and the whole structure would slowly deform until it became, inevitably, a sphere. It's not just that roundness is common, it's that roundness is unavoidable. Even black holes, the strangest objects in the universe, are thought to be perfectly spherical. Their gravity is so extreme that space and time themselves wrap around into a shape of perfect symmetry. The universe seems to have a pattern, from the smallest droplet of water to the largest star. Whenever matter yields to gravity, roundness is the final result. So when you look up at the sky and see a glowing orb, whether it's the moon, Jupiter, or some distant exoplanet, you're looking at the handiwork of gravity, the quiet sculptor of the cosmos that never stops shaping the universe into balance. And that leads to a deeper question. If gravity can shape worlds into perfection, then what unseen forces are shaping us? Don't forget to like, share, and subscribe to WiseUse, where every question brings you closer to understanding the universe.